to get an idea of the room I'm working with, how many of you do not use React Native? Okay, I can, no. No, it's fine, it's perfect. Actually, how many of you, for how many of you, this is like your first meetup ever? A few of you? Okay, that's perfect. Then you're my ideal audience, actually. Because I'm pretty sure that by reading this title, which is like React Native, the past, the present, and the future, you're probably like, what? What can it be talking about? Like React Native is something, it's not like the history of humanity, right? And who's this guy? Well, okay, let's start with the second question. I'm Lorenzo. If you're on Twitter, you probably have seen me. I'm there way too much. My handle is the same one I use on GitHub and everywhere else. It's Calcet. So probably that's why you may recognize me from one of my avatars. I've been a React Native developer for more or less 3 years now. I'm going for the 4th, if everything goes well. And for the past year and a bit, I've been a core contributor to the main React Native project, which is something that usually is a bit complex to transmit because I'm not working for Facebook, but basically I am partially. And what I mean by that is that usually you can see me in the issue section, maybe closing your issue and be like, ha, you didn't put a repro, so fuck you. Or probably you've seen a release, you may have seen my face next to that release. And lately I've also been trying to make the React Native community organization a bit more structured. And I'll go back to that. So let's start with the past. So in a way, React Native has a really complex history. So the best way I could think of it describing it is by basically saying, okay, how about when it started, it was like the dark ages. Let's try to get everyone to the same step 0 so we can then work on it. So basically, a long, long time ago, in 2013, the Facebook team that was working on the mobile apps was sort of struggling with the main issue they were facing, which is working on 2 separate platforms with proprietary code with a lot of complexities related to iteration and release cycle. And if you're a native developer, you know what I'm talking about. Like, anytime you would submit a new app to the App Store, you would like pray the gods that in a week or so they would approve it and you could deploy it. And while they were doing that, they were looking at their colleagues' table that they were working on web, and they're like, why they do get to use the cool toy? React was super fast to iterate with. It was way quicker, and everyone, of course, was trying to capitalize on that fastness of like iteration, and also the fact that it was using JavaScript to, reach a lot of different audiences. So basically, in a couple of years, what they did was to create some sort of connection between these 2 realms. And what they did was to introduce this bridge, this element in the middle, which is, in a way, fairly intuitive, right? You have a full native app. You put something, sort of like a garden. You put a wall around it, and then you put JavaScript in there. So JavaScript can do all the mess it wants, but it's still in a native app. That way, you could use React or something really, really close to the React used on web, but on a native application. So that way, you can finally start to see those fast release cycles and improvement coming from the React approach. After they presented this, and now we can skip and see what happened, basically, something clicked, we could say. A lot of companies started using it. Like, Facebook now has something like 15 different apps built in React Native, but even companies like Microsoft, Twitter, like if you ever used the light version of Twitter or the new Twitter, like both of those are made in React Native. Or like even Amazon is using it a lot. Like I was speaking earlier with a developer, and I was mentioning that apparently in February, Amazon did an internal conference for React Native, and they had like something like 600 engineers showing up, which is crazy for me. Of course, there are also many more startups using it, and that's also why I started using it. I was working for a startup. They were trying to save some money, and they were like, you know what, React Native seems the right way. But not only that, it's not like all about like the money. In fact, people started realizing that this approach was also working to target many more platforms than expected. It wasn't only good for Android and iOS, but like literally, if you go to that repository, React Native Vanilla, you can start your project in like 10 different platforms, which is crazy. You can target TVs, you can target all the desktop platforms. And this is not going to stop. Like literally last week, I saw a guy that managed to do React Native CarPlay. So it's crazy. Not only that, though, like something also clicked in terms of the open source aspect of React Native. You see, React Native has a bit of a particular history, but the community really, coming from a web background, sort of like jumped on this project with the approach of like everything has its own repo. If I don't find something, I'm going to create a repo for it. I'm going to share the code with everyone else. And this is sort of why, along with the fact that I joined this project in January, that when GitHub published the Octoverse report, well, React Native was the second most contributed project with like 10,000 different contributors, which is something that it's great to see. And also, all the different issues that people were facing usually resolved into a new library. So like, if you ever use React Native, you probably had like navigation issues. So now there's React Navigation, which is really good, React Native Screen, which is super important. And basically, these libraries are also trying to solve some important limitations of the current implementation. You see, when I showed you earlier that graph, I was basically, oversimplifying a bit. And this schema I'm showing you right now, it's still a simplification of actually the real one. But the core concepts that are shown here, I think, are enough to go through all the different aspects of React Native. As you can see on top, we have React, which gets translated into JavaScript that requires an engine to be interpreted at runtime when the app actually runs. And to communicate to the native side, we have this massive bridge, which is composed by 3 different elements. In particular, the limitations mostly come from this bridge. You see, this idea of having JavaScript making its own mess in this sort of sandbox was great because it allowed to, not being thread locked every time JavaScript was trying to, mess things up. But at the same time, created a bit of an issue in the fact that to communicate with the native side, it needed to communicate through JSON objects. Like you were sending a JSON message through this phantomatic bridge, and then hopefully somewhere in the future, a new message would come from the other side back in, but you would have no idea. Like you cannot assure anything. It's like basically having these 2 realms separated by a big fog, and you're trying to communicate sending paper, airplanes. Like you're sending and then maybe somewhere something will happen. Also, there are a couple other limitations, in particular related to native modules. So let's say Bluetooth, in which, given this structure of like everything being separated, you couldn't really infer when something was needed. So you'd have to load all the native modules at the startup time. Like, let's say in one screen you use Bluetooth, but you never reach the screen, doesn't matter. On the startup of the app, you would have to load that module and have it there to be ready to use because you don't have any sort of proper communication. That said, the Facebook team realized that these issues were causing some, let's say, problems. So let's see what they're planning to do. What's going to happen in the future? What's going to happen when we move from the dark ages? Now we're sort of in the Renaissance in a way, like we're exploring now. We're making sure that it's something that we can rely on. And now let's see what's going to happen like in the future. What can we expect? And well, it's super exciting in a way, but it's also overwhelming. Like there's a lot to talk about. So let's start with a disclaimer. Like the approach I'm gonna sort of try to transmit is like still history in the making in a way. So maybe some things will change in the future. But overall, you can imagine that the approach that Facebook used was, okay, let's take each of these 4 blocks and ask ourselves this question: how can we improve on it and also make sure that whatever change we implement is going to be retrocompatible, which is not a small feat. If you've been using React Web, basically when there was the massive change between React 15 and React 16, when they changed the reconciler, that's the level of like retrocompatibility that they want to achieve. So like potentially you would not have to change anything in your code. So let's see what they're trying to do, right? Okay, step 1, React. How can they improve on this circa React Web? Well, of course, they can leverage on all the new changes that the React Web team has introduced into the main React. In particular, if you are sort of like keeping up with the latest announcements, like the ReactConf back in October, they've introduced a couple of concepts that are really, really important. I know you're probably thinking about hooks. I don't really care about hooks because, yeah, they're cool, but the really important things that they announced is actually the concept of concurrency and suspense in React, which is super, super useful because finally you can queue, you can prioritize what you want to visualize and render. And so first off, they can be like, okay, let's just make sure that we can, one-to-one replicate and have the main React new functionalities in React Native. And then they sort of thought it through and they were like, you know what? We're seeing more and more static typing in React. So probably most of you have heard about Flow or TypeScript, most likely TypeScript. And basically, by working in this new architecture, and we'll see more in a second, but basically what they try to infer is that since we're using good JavaScript code now, because we're using static typing, we can sort of infer through a tool what the native side wants. So like if I have my Bluetooth modules written in JavaScript with proper Flow or TypeScript typing, then I can sort of generate its native counterpart. And by using this idea, they created this tool called the CodeGen, which is super, super interesting, and it's going to be a main player going forward. One of the main reasons that I can like just throw it to you right now without insight into the other parts is that basically, if you now have full insurance of what one side needs, you don't need to check every time you send a message across that that's what they're transmitting. And that's really, really powerful because you're removing a whole layer of extra complexity. The step 2, how can we improve on having JavaScript and an engine to, interpret it? Well, to do this, basically the first step is to introduce basically a little bit of an interface between the JavaScript and the actual engine used. By doing this, the core idea is that you can basically separate the concerns, and by doing so, you can replace much more easily the engine, which is super powerful because in a way, this means that you're not strictly bound to using the JavaScript core, which is the one that Apple requires you to use if you're running any sort of JavaScript code on a native app, which means like you could use V8, which is the engine Google uses, or Chakra Core, which is the Microsoft one. And also by introducing this interface, one really powerful element that comes into play is that finally you would be able to create a proper communication interface between the native side and the JavaScript side. What does it mean? Is that basically you're removing the fog between the two realms. You have the possibility now, I cannot really see what it says in the slide, but I'm pretty sure it says something like you're able to have C++ having host objects that can literally directly connect the two realms. And this is super powerful because, again, we're removing an element of uncertainty. We don't need to have all our JSON messages sent completely in the blind, but we can actually know who needs to receive which message, which removes a whole lot of, thread locking caused by, jamming through the bridge. You don't need to have one bridge for everything because you don't know what goes where. You know precisely what everyone needs. And this is incredibly powerful too. And also because, C++ is a really powerful language, and it's also the only way currently native engineers working on two separate silos can share code between native apps. Like if you talk with people from bigger companies, I cannot make names, but basically C++ is the only way they can sort of share code between two code bases currently. So by introducing the JSI, what you can do is basically open the door to all that code that's already written and just say, you know what, bring it here. We're going to handle that. What the JSI open is also this restructure of the bridge. Basically, we can now take the elements that were into the bridge. So in this particular slide, I'm talking about the TurboModules, which is basically how to re-architect how the native modules are loaded. So as I mentioned earlier, before you didn't have any insight on what was needed when, so you would have to load everything eagerly at the start, and again, the message would go through the bridge. Now, by using the JSI, we can re-implement how native modules are loaded, and by doing so, we can know precisely what is needed when, because we can have a direct point of communication from the JavaScript saying, hey, I need this now, so it gets loaded and that instance will be staying. And also, again, you have a direct communication, so you don't need to send JSON messages through the bridge, which is really, really powerful. Similarly, when it comes to basically the rendering layer or React Native, currently it needs to rely on a third thread, which I call here the shadow thread, the shadow tree. And I don't want to go too much into detail, but basically what was happening before is that you would have your JavaScript, it would have to go to native, then it would have to go back, it would need to be calculated, and the new tree would need to be resent into native so that you would know what to show. Now, through the use of JSI and the reimplementation called Fabric, which again is only the reimplementation of the rendering layer, this way this shadow tree is created is completely different, and it's directly in C++. So again, you would have both sides constantly knowing what's happening, and also you're relying on C++ to be the source of truth, which again is not JavaScript, which is great. So again, the bridge would get split into these two main elements, the TurboModules and Fabric. So if we were to get all of this together, all the new implementation, what we would have is this kind of element, right? We would have React, we would have the CodeGen that creates the interfaces needed by Fabric and TurboModules using the JSI, and the JavaScript code would still go through the JSI, and those two elements would allow for direct communication with the native side. It's quite a challenge, right, to move back and forth between the old architecture and this new one. So I'm pretty sure some of you are already thinking, okay, but when's going to happen? Well, actually, it's sort of already happening. It's mostly happening in the open. The React elements I was mentioning before, so the concurrency and suspense have been sort of partially already being released. A portion of the suspense implementation is still not out yet, as far as I remember. The CodeGen is being developed in the open, as it is Fabric and the TurboModules, which means that if you look into the main React Native code base, you can find the code. And the cool thing is that by seeing the code there, you have the insurance that Facebook is using that code in production. So like, think of the Marketplace tab in the main Facebook app, that's running that code. So you have an insurance that they're currently testing everything. And if something would break, they would notice first. So we're sort of safe by any major complications. And about the CodeGen is a tool that's currently in development. It's in the main React Native repo, and it's basically the second element of a new side of the repo, which is basically we're trying to make it into a monorepo. So like The new ESLint configuration is going to live in a monorepo. The CodeGen, again, the CodeGen is a tool, so it's not part of the architecture. It's something that gets run manually. Ideally, you could imagine that running in a CI step, like when you do a push to your project, in one of the CI steps is the CodeGen, and it makes sure that the interface files are the same. If it's the same, it means that like you can do a code push release of that code or not, which, I mean, aside from all the things that it would bring to the new implementation, it's so good, because I don't know how many of you know about like the possibility of over-the-air updates in React Native, but it's super, super cool. We can talk a bit more about that later if you want more details on that. But yeah, so all these elements are sort of happening. The real element that's currently out is the JSI. You can think of that as like already present in the latest 2 releases. So you may want to try to use it. It's not really documented at the moment because it's a bit in early stage in a way for like external consumer approach. But aside from that, we can sort of summarize what I've just shown you into, well, will it change my code? No, not really. If something changed, it's because you wanted to use hooks or you wanted to use suspense, but you're not forced to change anything. So technically speaking, just upgrading your code once this is all out will be enough. Will this fix the issues that probably you're all having about like gesture handling or the panel responder or navigation? Not directly. And that's because this is, again, a re-architecture. This is an enabler for having better solutions for those kind of problems. And hopefully we have like direct communication with most of the people working on the libraries that I've shown you earlier. So we're going to try to have new implementations of those solutions out by the same time that these releases are out. So most likely, these will enable for so many more good solutions outside. And also, how can I, how will I know when all of this is ready? Well, it's going to be communicated. It means like you're probably going to see a blog post, you're going to see something, and it's sort of like a buzz killer, right? Well, yeah, that's true. And that's why actually there's one more thing I wanted to pull, a Steve Jobs on you. And basically, probably the few people that were still awake when I was speaking earlier realized that I didn't actually go through the first step, like what's happening with the native side, why it looked different. Well, that's because it's basically a meta effort. It's not really part of the re-architecture, but it's happening at the same time, and it's called the lean core. What this is basically reducing the main code base size to remove all the elements that are not strictly necessary, so that they can be, first off, better maintained by people from the community, and also would remove like an extra weight, that weight from your app. Like if any of you has done a release, an iOS release, like in the last couple of weeks, Apple, of course, decided to change their policy around what information you need in a configuration file. So all of a sudden, basically every person had to add 2 extra lines to this configuration file just because of one module that was in the main code base that we are also planning to release as soon as possible, so that you won't have to go through this new extra step and having these 2 configuration lines, which don't really make sense if you're not using it. But like this kind of approach of lean core is really trying to make sure you're not carrying any extra weight with you. And again, basically giving more focus to each of these elements so that the maintenance over that can be better. Because you see, one other thing about React Native, which is really, really powerful, is the aspect of the community. The React Native community has been a part of this project since the very beginning. Like, the collaboration has always been super strict. Like myself, I'm not working for Facebook. I'm here simply because I'm part of the community and I collaborate with them. I try to help in making it better. And like, for example, even just the fact that the release cycle is something that is completely handled by people outside Facebook, it's really empowering. Sometimes it's a bit complex, but at the same time, it really means that the people working on the things are the ones using them, which goes back to the Lean Core effort. And also, since the start of the Lean Core, we are sort of trying to step up our game with the React Native community organization, where we host all these extracted components plus others. And we're gonna have better guidelines. We're gonna basically try to set the bar for the standard in terms of how React Native code should be written. And if you wanna go and have a look at what we're discussing in how to make it possible, we have a dedicated repo where we discuss these kind of things. So yeah, actually concluding this time. Well, the re-architecture, it's really, really a huge deal. It's gonna enable us to write apps that would beat any kind of performance barrier that we are currently facing. And through all these elements, basically, potentially you won't ever have to change your code just because. You would have to just update your app, and magically your app will be so much better. And this is really, really, really cool to think. Also, given this new element of C++, you would be able to target many more platforms in a way easier way. And like, just to mention one, which is always in the back of my mind, is that basically, I was talking with the engineering manager at PlayStation, and he was mentioning that now, through C#, basically, so C++, C#, we can even reach the Nintendo Switch as a platform, and that made me giggle. And also, yeah, as I briefly mentioned, the community is literally one of the best in the world. It's not by chance that we got that second place in the Octoverse, and I'm pretty sure this year we're gonna be probably still in that area, because no one is stopping right now. Everyone is moving super quickly. And of course, if you want to get involved, please come talk to me. I can, tell tales about the community for hours. So yeah, thank you for having me. And of course, feel free to reach out. Thanks to Michael, thanks to the sponsors for having me. I hope I didn't bore you too much. And if you have any questions, now's the time. Thank you.
I can ask a lot of questions, so I'll try and keep it quite simple. So this concurrency and queuing business, is this happening in the JavaScript's end of the world or somewhere beneath?
Okay, so
JSI layer, or exactly how is this going to work?
Okay, so the question is, how is this React concurrency gonna play in the React Native, in the new structure? So basically, it starts with the JavaScript. So it's basically the React code you write. Basically, you can define priorities through like suspense and like React lazy, these kind of things in your code. And then basically the JavaScript code that gets translated from the code you write gets passed to Fabric, and Fabric is going to have 4 queues. Basically, it will understand through JSI how high the priority of the JavaScript code that you've written for rendering UI is into, and basically you would have 4 queues. Basically, it's synchronous and direct, synchronous and batched, asynchronous, direct, and asynchronous batched. And like, to give you an example, currently 99.9% of the UI commands are sent through, like currently the Bridge is only doing async batched. So like you would imagine the code you write being more smart by its own and being able to move itself through 4 different queues. And of course you'll be able to you will have some flags that will enable you to say, oh no, this is a high priority rendering. Yeah, basically you will be able to control what goes into those 4 queues at any point, which, asterisk, that's probably how it's going to work. Fabric is still working, but that's the idea. You're going to have these queues. I can send you the link to some more like detailed documentation.
Next question is about translation from case of iOS, it's going Objective-C to C++.
Okay, so the question is basically how can you use C++ in the native platforms in a way? Like how does it get translated?
I'm less clear how it works in iOS. On the Android's world,
Yeah.
where it's going through
So
various
basically,
into C++ via GNI, the old Java native interface.
exactly.
Now,
It's so cool when they reply to their answer.
son of
So
a
the question is like so much easier.
here who's programmed C++ and Java some 20 odd years ago
Yeah.
will know about this. This was the old glue in the days of Corba and other obscenities.
Yeah, exactly.
And GNI was just bullshit.
I agree with that because I don't really like Java. Yeah,
Fine,
yeah,
but it was seriously dangerous.
yeah.
You have to describe it as, well, polite words can't be used to describe
Okay.
GNI was like then.
It's
References to GNI were extremely difficult to find.
yeah. Okay, so just to recap it a bit, because I think I wrote it in the slide, but I didn't mention it. So the reason why C++ is so powerful and it was chosen is because both Android and iOS as a platform can understand that language. So in iOS it's quote unquote fairly easy because if you think about it, Objective-C, which is one of the two main languages used by iOS, is nothing more than like a super strict version of C. It's sort of like TypeScript to JavaScript kind of relationship. In Android, and you may have not known this, but basically when you write Java or Kotlin, already right now it gets translated down to C++ through an interface called the JNI, which is Java Native Interface. And so yeah, basically Android in a way is already using C++ anyway. What was the question?
Well, the problem as it was some 20 years ago
Uh-huh.
is if you had a null pointer in your C or C++,
Mhm.
and that translated up into your upper layer, which was your
Right.
Java at that time,
Yeah.
your JVM just disappeared. It just turned to toast. Which
Oh,
was
okay, I see what you're saying.
this
So,
was sort of
uh-huh.
1998
Right.
kind of where Java was in
Okay.
its infancy, and C++ was not that well.
Right. So basically,
Things have moved on from then.
yeah, I think so.
Java's almost dead. C++.
Yeah, Oracle is making sure that Java is dying. That's for sure.
It's recorded.
No one knows. Just
But you've also got the problem that
yeah.
on Android, the Java that is there is a very curious legal agreement between Oracle
Yeah.
and Google, I think it is.
Yeah.
Eventually agreed some clause that's based on the GDK 1.6 or something. Which
Yeah.
is prehistoric Java terms.
Yeah.
It might have moved on a bit, don't know.
Yeah, we can speculate more about that because I think Google is sort of doing other things too. But basically, the question could be like, how can we ensure that the C++ code that we write won't break everything? Because if you're going from the native from C++ back up, what if something goes wrong here? What's going to happen up there? Well, I think that the main way to talk about this is that that's one of the reasons why there's the CodeGen. So all that process is automated. Like the CodeGen tool is basically creating those interfaces. Yeah, exactly. Like you would hardly ever. Yeah, of course. But it's still. Yeah, of course. Again, it's still a work in progress. Probably these kind of edge cases are being found right now. Okay. Any other question? Yes.
There is a new markup tool called Flutter.
Okay. Sorry. Yes.
Okay, so what do you think for the future?
Okay.
Is React Native will take hill, or do you think Flutter might take it over because it's probably started in GitHub?
Okay. So the question is, what do you think about Flutter, basically, right?
No, I'm thinking, what I'm asking is in comparison to React Native, which
In
is
co-
a
okay.
major competitor that is coming up, so I mean,
Okay.
probably for the beginners, what
Okay.
would be
All right.
the point of thinking?
Okay, so what is like Flutter versus React Native? More or less. Okay, so I think that React Native and Flutter are sort of trying to solve the same issues, which is people having to work on two code bases that do exactly the same thing. And the only reason they need to do you need to have two people working on these two code bases that they're proprietary. So both are saying, you know what, I'll find a way to write code once, and then you can deploy on both platforms. There is a core difference in the way they approach it. So like React Native is sort of saying, okay, this is all native and it's controlled by JavaScript, like in the graph. Like you would have native and you would have JavaScript. And that's, again, it's a limitation or an advantage, question mark. With the new architecture is probably an advantage in some scenarios even. What Flutter is doing, from my understanding, is that basically they ask you to write code in Dart, which is another language made by Google. And then what they do is a sort of a compiler that translates what you've written into pure machine code, machine language code, or like it doesn't go through the native step. So that basically black box that you've created is going to be super performant on the machines that really like that code, that assembly code. Because again, it's assembly, so it's super low level, so it's going to be super performant. But at the same time, it's, and this is my understanding, so don't at me on Twitter, please. My understanding is that it's not really native. When it comes to developer experience, I think that language-wise, React Native still has the edge because JSX it's more pleasant to write. But in terms of like tooling, like the Flutter CLI, it's really, really good. The documentation is super good. So it's probably like a you do you kind of scenario. Any more questions? All right, then we can go and have a drink together. All right, thanks.